in this video I want to work through a problem where, if you can see here on our screen, that in a recent poll, a random sample of adults in some country that are 18 years or older was asked, when you see an ad emphasizing that a product is made in our country, are you more likely to buy it, less likely to buy it, or neither more nor less likely to buy it? And here are the results, as you can see from this table right here. Okay. But before I dig too deeply into this problem, let me just show you something that that we're going to need to know about, and that's something that we're going to need to know about is called the let's see if I can write it right here. It's called the general multiplication rule. Right? The general multiplication rule. And the general multiplication rule, or sometimes the same rule is called the conditional probability rule. Right? Sometimes it has another name of conditional probability rule. Anyways, whatever you call it, whatever your book calls it. In fact, I'm going to show you two versions. Let's call this version number 1 here. Okay. Sometimes your book might show it this way: the probability of E and F. Okay, and I showed in a previous video, by the way, that the general addition rule, has an or sitting right here between E and F. It's the probability of E or F. The multiplication rule, the multiplication part of it, has to do with the word and that's sitting right there in between E and F. Okay. Well, anyways, the general multiplication rule says that if you take the probability of E and you multiply it by the probability, and this is how you read it now, of F given that E has occurred, or if you multiply these two things, you'll get the probability of E and F. So that's one way to write this. I'm calling it version 1 here. One way to write this multiplication rule. Perhaps another way to do this, I'll call it version 2. Right? Another way to do this is, and it's really simple. Look at this right-hand side over here. If you divide both sides by the probability of E, right? Divide both sides by probability of E, it ends up on the denominator over here on the left side, and I have this conditional, right? That's where the conditional part comes in. This conditional means, pointing over here. It's F given E. E is the conditional part of this little term right here. So version 2 says, okay, let's go find the probability of F given that E has occurred, right? Well, again, just simple algebra. You divide both sides of this first equation by the probability of E, and you see it looks like this. Probability of E and F all over the probability of E. Okay, so we're going to use, I think I'm going to use the second one here. Right? I'm going to use the version 2 to work out this problem that we have over here. Now, whoops, I didn't want to write that. So let me show you how this works here. Okay, going back to my problem, the first question is, what is the probability? This is part A. What is the probability that a randomly selected individual is 35 to 44 years of age? Right, that's what we're looking for. 35 to 44 years of age, given that the individual is more likely, that's a key word right there, more likely, all right, to buy a product emphasized as made in our country. So let me do the setup here. Let's go back over here, and let me show you the setup and what we're going to do. And, all right, and keep in mind, we're going to use version 2, I think, here of this general multiplication rule. So my setup is this. We want to know what's the probability. What is the probability that we end up with a 35 to 44-year-old, all right, that we choose one of these persons, given that they are more likely to buy locally, all right, that they are more likely. Well, this part right here, let me show it to you in a different color. This part then right here is going to be our F, and this part over here is going to be our E. All right. And so using this right-hand side of the formula, let's go first find the probability of E and F we're going to divide that by the probability of E. Here's what I mean. Right? We'll go back to black or some other color. So here's what I mean. What is the probability of E and F? What's the probability that we have a more likely person, right? They're more likely to buy locally, and they're between the ages of 35 and 44. So that's what my numerator is going to be. It's going to be an E and an F. And do you see that the 35 to 44-year-old is in this column right here, and more likely, that's in this row right here, more likely is in this row. So where they intersect is that 372 right there. And this number 2287 is my total. So what I've got so far then is I have 372 over my total of 2287. That's my numerator. Okay, that's the and part right there. That's the and part. Now let's go find the probability of just E, and E again being is more likely. Okay, more likely. So the probability of that E of more likely, let's see, that total is right here. That's 582. Right, so sorry, no, I'm doing that incorrectly here. Let me erase that, what I just wrote. Forget that. All right, do you see that the more likely is actually this one right here? Look, this row of 1405. That's the more likely. Okay, so all of the more likelies is 1405 out of 2287. I'm going to do that down here in my formula. So my denominator, right, my denominator is 1405 all over 2287. Now, if you learned way back in the day that when you have a fraction divided by another fraction, we actually don't divide fractions, we multiply and flip the second one, right? That's called reciprocal. So it really turns out to be 372 over 2287 times, right? And then it's the reciprocal of this denominator here, so it's 2287 over 1405. I'm just showing you this once here, but do you see that these totals of 2287 are going to cancel? So I'm really just going to work out on my calculator. Let me bring this down a little bit. So I'm really just going to work out on my calculator. I'm just going to work out 372 divided by 1405. And if you round this off to 3 decimal places, you'll see that you get an answer of 0.265. Right, 0.265. There's our final answer on that one. Now, let's keep going with this problem here. What if we change it up a little bit, all right? What if we change it up and say, okay, how about this next part here? Meaning, this time, what is the probability that a randomly selected individual is more likely to buy a product given that the individual is 35 to 44 years of age? Okay, so they're asking the same question, but they're asking it backwards this time. I hope you see. Right? This time they're asking it a little bit backwards in that, let's see if I can get another page to show up here. Oops, that's not what I meant to do here. Let's get rid of that. So what I'm going to do then is I'm going to bring up another page, and I'm going to write on here, okay, this time we have the probability that we have more likely, right, more likely, given that this person is between the ages of 35 and 44. Now that may look like what we started with a while ago, but it's not the exact same thing. This time, I hope you see that this is going to be my F, and this is going to be my E. And if you go to the setup, you'll see that I'm looking for the probability of E and F. Again, this is coming from the general multiplication rule, divided by the probability of E. All right? And working this out here, do you see that the probability of E and F was exactly the same as before? So that's my 372 over my total of 2287. But this time, the probability of E is different. Right? This time, it's not going to be 1405. In fact, let's go see. What's the probability that we have a 35 to 44-year-old? Well, do you see that right here? Look, the probability that we have a 35 to 44-year-old, that's this column here, is 582 out of 2287. All right? So it's 582 is going to be my denominator, 582 out of 2287. And again, our same rule of flipping and multiply is going to happen. Turns out that these guys are just going to go away. And I'm left with 372 over 582. And if you work that on your calculator, you get an answer of 0.639, right? 0.639 is the answer to that one. All right, that's using the general multiplication rule. I guess there is one more part to this question. Maybe I should hit that up too. And that part is this. Hey, are 18 to 34-year-olds more likely to buy a product emphasizes made in our country? All right, we're looking at 18 to 34-year-olds, and are they more likely? All right, that's what they're asking here. Are they more likely? Well, let's go look at the 18 to 34-year-olds. Hey, do you see that right here? This is our 18 to 34-year-old column. And are they more likely? That's this row. Look, that number is 237. Of all these other numbers over here, right, 404, 392, 372, 237. 237 is the smallest of the more likely row, isn't it? So I'm going to answer probably for this one here, no. I would say no. They're probably less likely. Oh, I hope that helps.